Let's talk about the characteristics of public cloud. Ownership. This is the resources that the organization or end user uses. Example, storage, processing power, CPU, memory. Resources do not belong to your organization that is utilizing them, but rather they are owned and operated by third parties such as cloud service providers. Multiple end users. Public cloud modes may make their resources available to multiple organizations and not just your organization. Public access. The public cloud provides access to the public. That means that the resources in the cloud provider's location can be accessed through the internet. Availability. And this is the most common cloud type deployment model where the cloud provider ensures the availability of your data and machines. Connectivity. Users and organizations are typically connected to the public cloud over the internet using a web browser. Skills. The public clouds do not require deep technical knowledge to set up in your organization. You do not need a lot of resources as well. All you need is a laptop, a desktop device, or any small platform that will have a browser and very basic internet connectivity, and that's all. The skills are all managed by the public cloud provider. Let's talk about private clouds. When we think about the term cloud, it always doesn't mean that it's with a third-party provider. It could be within your organization as well. Private clouds are owned and operated by organization that uses the resources from that cloud. The organizations or enterprises will create their own cloud environment with their own data center. That means the resources, hardware, storage, and everything else that's required to make a cloud is within the data center of the enterprise. And that means that employees of the organization can use a self-service provisioning portal to log in to the private cloud and then create computing resources. The organization, although, always remains the owner and is entirely responsible for the operation of the services they provide. A good use case for this private cloud scenario would be when an organization has data that they really do not want to put in the public cloud. Perhaps there could be legal reasons. For example, medical data that has to be compliant with HIPAA standards cannot be exposed publicly. Another scenario is where the government policies require specific kind of data to be kept in the country privately. In the next video, let's take a look at the characteristics of private cloud that actually make it private. In the previous video, you understood that the private cloud is owned and operated by individual enterprises. Let's understand the characteristics of private cloud. Ownership. The owner and user of the cloud services are same. If you compare it with public cloud, the owner, which is a cloud owner, and cloud user, these are two different things. Cloud user is us and cloud owner is the public cloud provider in case of public cloud. But in private cloud, the owner is the company and user is also the company because everything is lying on premise. Everything is lying inside your LAN. Hardware. The owner is entirely responsible for the purchase, maintenance, management of the cloud hardware. Users. A private cloud operates only within one organization and cloud computing resources are used exclusively by a single organization or single business. Connectivity. A connection to a private cloud is typically made over a private network. Like we said, it is within your LAN environment, and that will make it highly secure. The connection to your private cloud is not available on the public. That means you cannot access those private resources in the private cloud from the public or internet environment. You can only access it from your intranet. Skills. To build your private cloud, it will require a deep technical knowledge because you then have to maintain, set up, and manage your private cloud infrastructure. The last one in this section is hybrid cloud. A hybrid cloud combines both public and private cloud environments. And that means that hybrid clouds will allow you to run your applications in most appropriate location. An example of hybrid cloud usage scenario would be hosting a website in public cloud and linking it to your highly secure database hosted in your private cloud infrastructure. Hybrid cloud scenarios are very useful when organizations have some things that they do not want to put it in public cloud, possibly because of legal reasons. For example, you may have medical data that you don't want to expose that in public. Another example is one or more applications that run on old hardware that really cannot be updated. In this case, you want to keep the old system running locally in your private environment and connect it to the public cloud for authorization or for storage. In the next section, we'll learn about the characteristics of hybrid cloud models. When you combine the power of public cloud and the advantages you have in the private cloud, what you get is a hybrid cloud. In this video, let's learn about the advantages or characteristics of hybrid cloud environment. Resource location. It clearly means that there are certain specific resources that will run in public cloud and other dependent resources that will run in your private cloud infrastructure. Cost and efficiency. Hybrid cloud models will allow an organization to leverage some of the benefits of cost, efficiency, and scale that are available in public cloud models, so you can take advantage of both private and public. Control. Your organization will retain most of the management controls because you also have your infrastructure running in private cloud. Skills. Keep in mind that your organization will need considerable amount of technical skills to create, build, manage, and maintain the hybrid cloud environment, because now you have infrastructure to maintain in private cloud, as well as the integration components with the public cloud must be maintained by your technical team members. So far, we learned about what is a public cloud, a private cloud, and then a hybrid cloud as well. Let's talk about the types of cloud services. For example, infrastructure as a service, platform as a service, and then software as a service. We'll also learn about what are the advantages of them, what are the characteristics of each one of these cloud services, and what are the usage scenarios of infrastructure as a service, platform as a service, and software as a service. Do you know what it takes to build an infrastructure for an organization? And when we think about infrastructure, think about the underlying components of any application. For example, a server, hardwares like routers, switches, firewalls, the underlying cabling, and then everything that goes with the physical infrastructure. You need a lot of security, monitoring, log access, load balancing, clustering, storage resiliency, backups, and this list can just go endless. These are the services that any application will need for it to function properly. The infrastructure as a service provider will supply this range of services to you as a service. So you do not have to go ahead and create that infrastructure on your premise. In infrastructure as a service, the cloud provider will host the infrastructure components that I just listed, and it will be hosted in their data center. All the servers, storage, and the networking hardware, as well as the hypervisor layer, will all be provided by the cloud provider like Microsoft Azure, Amazon, IBM Cloud, etc. So you do not have to worry about the underlying cabling or procuring the hardware for your virtual machine. As an infrastructure as a service customer, all you have to do is have access to the internet and probably a subscription with the cloud provider. And then you can provision a virtual machine of whatever configuration you want. You can go ahead and transfer all the workloads to the cloud provider in the virtual machine in the cloud. Cloud customers can use cloud providers, racks, switches, and firewalls, and that can be provisioned in a matter of minutes. Any cloud computing model requires the participation of a provider, and that includes infrastructure as a service as well. The provider is a third-party organization who's selling the IaaS services. For example, it could be Amazon Web Services, Google Cloud Platform, or Microsoft Azure. The businesses might have to deploy a cloud environment, becoming their own infrastructure services. Organizations will choose infrastructure as a service because it is very easy, fast, and cost efficient to operate a workload without having to buy and manage the underlying infrastructure. IaaS is the effective model for workloads that are temporary, but some of the organizations have gone for permanent workloads as well. Infrastructure as a service is the most basic category of cloud computing services. With infrastructure as a service, you rent IT infrastructure servers, virtual machines, storage, networks, and operating systems from a cloud provider on a pay-as-you-go basis. So it is instant computing infrastructure because they are provisioned instantly, they are managed instantly over the internet, and when you don't want it, you can just decommission that virtual machine. Remember that in infrastructure as a service, there are no upfront costs. Users just pay for what they consume. The user is responsible for purchase, installation, configuration, and management of the software inside that operating system. But remember that the cloud provider is then responsible for ensuring that the underlying cloud infrastructures, such as virtual machines, storage, and networking, is always available for the user. So when you use infrastructure as a service, ensuring that the service is up and running is a shared responsibility. In the next set of videos, we will also learn about what is a shared responsibility model, and there's a lot we need to talk and understand about it in detail. In the next video, we'll learn about the common usage scenarios of infrastructure as a service. On your local data centers, in your office, you may have workloads running on your virtual machines. And if your organization is looking to adopt cloud as a platform, then you may want to do a lift and shift of those virtual machines to the cloud. And you may want to do that on infrastructure as a service. Typically, IaaS facilities are managed in a similar way as on-premise infrastructure, and that provides an easy migration path for moving existing applications to the cloud. There are teams that can quickly set up and dismantle test and development environment. So if you would like to bring new applications to the market faster, then IaaS is the way to go. Infrastructure as a service makes scaling development testing environments up and down fast and economical. If you would like to run websites using infrastructure as a service, then all you got to do is build a new virtual machine in the cloud, typically AWS, Azure, or Google Cloud Platform, and then start installing Apache, Tomcat, and then host your web application on it. So, infrastructure as a service is also used for web hosting. Organizations may want to avoid the capital outlay and complexity of storage management, which typically requires a lot of skilled staff to manage your data, meet the legal and compliance requirements. Infrastructure as a service is useful for managing unpredictable demand and steadily growing storage needs. It can simplify the planning and management of backup and recovery systems. So infrastructure as a service is also used to store your data, backup, and perform recovery when required. The developers are responsible for building great applications that we have today. Developers are very good at writing great code, making sure that the application works and performs at its best. But one of the major roadblocks that developers have is they do not have an understanding of the underlying infrastructure where the application will be hosted. For example, the developer may not know what encryption is and what backups are. The platform as a service will be providing an environment for building such applications so that the developer does not have to worry about those concepts. He just have to focus on writing the best code. Platform as a service provides an environment for building, testing, and deploying software applications. The goal of PaaS is to help create an application quickly as possible without having the developer to worry about managing the underlying infrastructure. For example, when deploying a web application using PaaS, you do not have to install an operating system. You do not have to even take care of the Windows updates or install the antivirus on the machine. PaaS is a complete development and deployment environment in the cloud. Resources are purchased from cloud service provider on pay-as-you-go basis and accessed over a secure internet connection. There are no upfront costs and users pay only for what they consume. The cloud user or the developer is responsible for the development of their own applications. However, they are not responsible for managing the server or the underlying infrastructure. This will allow the cloud user or the developer to focus on the application or the workloads they want to run. The cloud provider is then responsible for operating system management and network and service configuration. Cloud providers are typically responsible for everything apart from the application that the user wants to run. Cloud provider provides a complete management platform on which the developers want to build and run the applications.